All right, now we're going to move on to some elevator problems, and hopefully maybe I can get this into one video. We'll see. It's not too long. But I always get questions about elevators and how they work, like how it's happening. So I want us to be very clear. When we are dealing with the elevator, we are focused on just the man. So just the man, not like the elevator, the cables, anything else. If you were interested in like everything, there would be more forces. But I'm only going to focus on this guy. So I ask you, imagine you're in an elevator and you start to move up. What are the forces acting on you? And I hope that you would come up with two forces. I hope that the two forces you would determine at this point, and we've done a lot of these, is you have gravity going down and you have normal going up. Now the question is, this normal force, how big should it be? If you're just standing on like ground normally, you would say it's equal to Fg. But let's look at what is happening in this elevator. An 85 kilogram man standing in an elevator pushes the button for a higher floor. He starts from rest and accelerates upwards at 2 meters per second squared for 1.25 seconds. Is this balanced or is this unbalanced? So I ask you, how do we know? This is unbalanced. I know this because I'm accelerating upwards at, I don't like that color, accelerating upwards at this acceleration. So you're accelerating unbalanced. All right. They tell you upwards, so that means if I were to draw this, I should expect that there is more up than down. And so I'm going to make a VAD to describe this. So I have Fg, this is the weight of the man, and then this is what the elevator is doing. What I'm saying is that the elevator needs to push you more than your weight in order to accelerate you upwards. And I don't think that's usually too confusing for most students. So elevator is pushing you more to get you up. The remainder, when these cancel each other out, like this part cancels out with this part, the weight of the person with Fn, what you're left over with is F net. All right. I'm going kind of quickly, so hopefully y'all are able to pause the video, look back at the work I'm doing, but I'm trying to move quickly so that we're not stuck on this stuff. So that means Fn is equal to, if I'm just using my VAD I've created here, I would say the length of this Fn arrow is equal to literally the lengths of Fnet and Fg. To be clear, even though I've declared directions already, but these vectors, you should keep them all positive. And if you end up with a negative number, that means something else. But when you're doing this method of using the VAD to come up with equations, keep them all positive. We'll see what ends up happening. All right, now that we know all this, let's solve for Fg, for Fn, for Fnet, and acceleration. So we always want all the forces in our force diagram, Fnet and acceleration. Sometimes, if it's balance, it's easier, but if not, I'm also going to want, they give us some other information. Let's just see if we can get delta x and delta v and t. Let's see if we can get these out of there. So, all right, let's start solving some things. So Fg, I'd solve that with mg. So it's going to be 85 times 10. And that's going to be 850 newtons. Now I come up to Fn. Now, I have this equation here for Fn. I can solve for Fn. I don't have any other equations for it. I just have Fnet plus Fg. This works, like this equation I've come up with works only for elevator problems or for this very specific VAD. And you'll learn in other elevator problems it wouldn't work. So this very specific elevator problem, I have this equation I've obtained for my VAD. I cannot solve Fn yet. I need to see if I can solve for Fnet. Do I have another formula? Oh yeah, Newton's second law. Fnet is equal to ma. So if I have the acceleration, I can solve it. Look at that. I have accelerations 2 meters per second squared. I'm also going to put down that time is 1.25 seconds. Let's see if that helps later. All right, Fnet's equal to 85 times, I think they gave us, 2. So that means that would be 170 newtons. All right. Fn should be, according to this formula I have here, it should be 850 plus 170, and I should get 1020 newtons for my force normal. Let's just step back and say does that make sense? Does it make sense that my normal force is greater than my FG? And I think we prove, yeah, it should be, because I'm starting from rest and the elevator is causing me to move up. So my elevator has to be greater than my weight. It needs to overcome my weight to push me forward. All right. Hopefully all of that kind of makes sense to you. For this kinematic stuff, I'm going to move on to the kinematic stuff, and we're going to try to solve using the equations. Now, not the equations, through the graphs. And I kind of go back and forth what I think is better. I think it depends on the problem, what they give you, but sometimes, these graphs, I think these graphs, if you can make it work for you, is the better way to go. I know my object has constant acceleration at 2 meters per second squared. That's what they told me. And I'm just going to treat all of this as at 1.25 seconds. So 1.25 seconds. Let me redraw this. All right. So this is 1.25 seconds. I'll put this all the way up. I want to figure out how far I'm going to go in this time frame and how fast I'm going to end up going. I know I'm starting from rest and speeding up, so this is 0 meters per second, but I don't know my final velocity yet. I know I'm speeding up, so it's going to look something like this. I don't know my delta x yet. All right, so how can I solve for this? Now, all right, the way you solve all these problems, it's either taking areas or slopes. For example, I can take the area here. Let's see what this area gives me. The area of an AT graph gives you delta V is equal to AT. All right, well, I don't have delta V, so this would be very useful if I solve this. 2 times 1.25, I get my change in velocities, 2.5 meters per second. Hey, that's great. That is great because now I have the upper range of this triangle. And so if I solve for this area, what I'm going to get is delta x is equal to 1/2 times VT. Now, I know y'all aren't maybe used to what this, like, we did this in quarter 1, but for your midterm and for this upcoming quiz, you're going to want to know how to do some basic kinematic stuff. So I'm just trying to refresh y'all with what we've done in the past. 1/2 times 2.5 times 1.25. All right, I get 1.56 meters. All right, so that's what I get for this part kinematically. So hopefully this makes sense. My elevator, it traveled for 1.25 seconds. It was accelerating upward. I'm going to ask y'all to try to solve these next 2 questions for this elevator. See where it goes. The second problem, we are in like the middle of the elevator shaft. We're going at constant velocity. The third problem, we are slowing down to our desired floor. So I'll let you guys try to work on that and then try to see if you can solve the other equations. I think I'll end this video here and I'll pick up the rest of this worksheet over there. Please do these problems ahead of time. You'll be better off for it.